and sugar? Okay, I think sugar is what like sticks to it and makes it work. Let's follow up at the end. Did you put water on it or just dry it? Okay. 3 facts. Ready? Yeah, but you can go. People are still facting it. Did you guys get outside yet? It's pretty cold yesterday. Today or no? Thursday. It's supposed to be like 45 to 50 the next few days. Is there snow in the field? Oh, that's good. Even if it's freezing?
Yeah.
Really?
Yeah, they might go outside. I will be working again since running.
Alright, let me just talk about what's going on, because I don't know if it's obvious from this or not, but if I just hit, so this is a, let's say 90% confidence level. If I just hit sample, that's a sample size of 20, so here's 20 data points. And then there's the mean, and that little bar is the confidence interval like we just did. So in this case, remember there's nothing special about one sample, but in this one sample, did we capture the true population value? We did, because this mu is right in the middle of that bar. It crosses through that bar. So if I just hit more and more and more, all 4 of those have captured it, right? You see that? But did that one? That one did not. They put it in a different color, but it's kind of off to the side. Again, there's nothing wrong with that sample. It's just kind of luck of the draw. But if I did this over and over and over again, 90% of these would capture the value. All right, 3 facts. Gavin, you had one? Wait, one. That was one. Let's do one at a time. So I just want to talk about each one. So as the confidence level goes up, you can literally see the bar moving. So as the confidence goes down, I thought of another way to explain this too. I give you a fair die, or I'm sorry, I give you a coin. Here's a coin. I need you to tell me if this is a fair coin or if it's weighted in some way. Because you can make a coin that's 60-40, I need you to tell me if this is a fair coin or not. But I need you to be 100% confident. If you're wrong, you're going to die. How many times would you want to flip that coin? Forever, right? To be extremely certain. So you want a larger sample size to be more confident. If I said just figure out if this is a fair coin or not, but you don't need to be sure. Just take your best guess. Just be 25% confident. You could just roll it 10 times and be yeah, I'm pretty sure. You know what I mean? The more data you collect, the more confident you are that you're correct. So that's one fact. You can visually see it. I know I'm a visual learner. When I start moving this back and forth, I was oh yeah, that makes total sense. Everyone learns differently. But when I move the confidence level up, bars get wider. I'm less confident now, so the bars get narrower. That was one. So let me give you another fact. Mr. Aika. So the more margin of error I have, well now 99.5% of these should capture the value, so they got to be wider. And yeah, you're more likely. You're more confident that you have the true answer in there somewhere.
No.
Oh, say it again? I'm sorry.
If the sample size is bigger, I've noticed it's less likely for there to be extreme, really big extremes.
So the way we said that was, as the sample size goes up, what goes down? Standard deviation. So you can see on the graph up here, when my sample size is 15, just look at how wide those two things are. Well, now my sample size is 30, they got narrower. 100, it gets narrower. And then you can see with these two, the bigger sample size, it gets narrower. That was 2 facts. Those are kind of the 2 I was looking for. Did everybody have a third one? You can hit reset. That's a good third one. Yes, good one. All right. Okay. any sense or not. It says quiz on top and side. Alright, I'm going to kind of start this with you, but the goal here is we're trying to figure out which of these statements are true and which of them are false. So I'm going to do like the first few with you and then break it up into chunks. Alright, number one. If this method were used to generate an interval over and over again, so that's good because it's long runs. In the long run, it even actually literally says long run. 95% of the resulting intervals, and why am I saying 95%? Well, because that's what they did up here. So they took one 95% confidence interval and got this. They got 0.32 to 0.49, so right in the middle is 0.405. So number one says if I did this over and over again, in the long run, 95% would capture the true value. That is like a textbook perfect definition. That one is good. Number two is a tougher one to explain, but there's nothing special about your sample. There's nothing special about any one sample. And if I did a bunch of samples, 95 of them would capture the true proportion. But if you see the word chance or probability, it is not right. Your interval that you made either captured the true value of 1/3 on the board, or it didn't. It's not a probability. We don't really know the answer until we look at the long run. But if you ever see the word chance or probability, you can cross it out. And almost every time it says like your specific one sample, that's almost always where I'm helping. 95%. I'm sorry. I have 95% confidence in my methods. You would never get credit for saying that, but it's not wrong. I don't like that one, but it is correct. Okay, number 4. This says true proportion. That's good. That's what we're looking for. But this references your specific one sample, and there is nothing special about your sample. Number 5. Wrong for 2 reasons. We're not looking for the sample proportion. We're looking for the true proportion. And there's nothing special about this interval. Number 5 is incorrect. There are 3 more on the front page that are correct. I want you to try to find which 3 on the front page are. Don't flip the page yet. Because that's like a separate section. But try to find 3 more on the front page that are correct. And this is hard. Especially for math. Like when they give you this, math class.
It smells good. Like first,
it's like going away.
Yeah, it's.
Well, not everyone.
That is true. Usually it smells like doo-doo in this hallway, so anything else is better.
So it's counteracting the doo-doo.
Yeah. It smells better.
Thanks, Ella. 3 more correct ones on the front page.
No, I said the whole hallway.
Yeah, that was a little. The classroom would have been a little more offensive than the hallway.
No, it's just the hallway. I don't know why.
That's not. I can't put that on me. Not my fault. Freshman don't shine. kept saying last hour, like, and I'll say it again this hour, like, your sample is not special. And it made me think of, like I can imagine, I could very easily hear Mr. Packard saying, like, you are not special. So your sample is not special. Yeah, you might have said that. Everybody got one that they are willing to share that they think is correct or isn't correct. Like you can raise your hand and say 6 is garbage or 8 is correct or whatever you think. Give me anything. Got it. 8 is correct. You agree? Raise your hand if you agree that 8 is correct. Should. So that's got it all. It's got long run, and we're looking to contain the true population growth. That is a good one. The other ones that you can tell me it's right or it's wrong. Okay, eventually we're gonna need someone besides Gavin and Zach. Go ahead, Zach.
Is 9 bad?
9 is bad. What they're doing is taking the average of the two numbers, but again, that's just from one sample. There is nothing special about your sample. You are special. Your sample is not. All right, someone else. Joseph, what do you got? 12 is wrong. Why'd you say that?
Why?
Or do you not want follow-up questions?
Oh,
What do we know about your sample? There's nothing special about it. 12 is wrong. Anyone else? 13 is right. Do we agree?
yes.
13 is right. 95% of samples of this size, so like that implies to me that it's long run because it's like all the samples, and then we'll capture the true proportion. That's good. All right, we've had 4 males volunteer. What's up with the women in STEM over here? Got any volunteers?
No.
No.
10 is
10 is
doo-doo.
doo-doo, says. All right, 10 is doo-doo. Like I'm not even sure what that's saying. Like 95% of all Reese's Pieces. Yeah. So this talks about this interval. That's the simplest way to explain it. There's nothing special about this interval, so it's doo. I like that. Is it right or is it doo? Cap or no cap? What about 6? That is wrong because that talks about the sample proportion. I'm not looking for the sample proportion. Like I know the sample proportion. It's right there. That's not the point. I'm trying to find the population proportion. What about 7? 7 is doo-doo. That's a little tougher for some people to see. Because what's...
Why is 8 say sample proportion?
I was gonna say 8 says sample proportion.
Okay, yeah, you guys were talking about something. Before I go to 7, what was the question?
Well, you said that the sample proportion all like means that it's wrong, but 8 says.
So 8 says all the sample proportions, 95% of all sample proportions. So all of them, over the long run, will contain the true population.
We're not talking about specific.
So you're not talking about a specific one. You're talking about like all of them. Does that make sense? The difference. And then 7. Someone said 7 was doo-doo, right? So the reason. Okay, so repeated random sample proportions. That part's good. But this says like future sample proportions will lie in this interval. So like Heike's thing on the board when we did the rolling dice thing, it was what was it, 0.52 to 0.74 or something. Does that mean that 95% of all intervals in the future will have to lie within his interval? Is there something special about his interval? There is not. So when it says this one would lie in this interval, that's wrong. And then we got 11 left over. What do we think of 11? It's like shady. So this is like, I wish it didn't say this. If it just said using statistically correct methods, I expect to be right. 95% wrong, 5%. Yeah, that's good, but it's like, I behave in this way. I don't know, it's like a shady. But it is actually true. What that means is like if I do everything mathematically correct, I'll be right 95% wrong. Questions on the front. Go to the back. There's 2 correct on the back. 14 through 20. There's 2 of those that are correct. You're getting the substitution too. Even with the definition.
I don't know why I get that, but I just don't.
We didn't even do the. Oh, I showed you yesterday, right? There.
Yeah.
Okay.
But I like the UV better than the other one.
Yeah.
Yeah, I didn't. It doesn't make any sense.
Wait, what is it?
Like the other one you showed. So using video.
Oh, okay. That like shortcut thing.
Yeah.
We won't have to show both ways.
Oh,
I just didn't.
Oh, really?
I just need to know one.
You're just like, no.
I just started doing the practice ones, and I was like, I was like, send it.
I feel like I should have showed you like today instead of
I mean, it was not like no one liked it.
today.
I
But
was
like,
just
if you
like,
were more comfortable with method A when I showed you method B, you wouldn't have shown
Yeah.
that. So that's what I'm saying. Maybe
I mean, I still might have not.
you still might have.
Because if I like know one, I'm just gonna snip that one and snip the other one.
And the one you know is like the technically correct one. We good to go through these? Yes, no, maybe. Alright, according to my sample bag, and then they try to make a conclusion based on like my own one sample bag. What do we think of that? Do. According to my sample bag, and then they try to make a conclusion based on the data I got in my one sample bag. We are 95% sure, and then they just use the data from my single sample bag. So good. And then these get into like the kind of, I mean, we've talked about it, but that applet that I had you guys play with hopefully helped you with these. A lower confidence. So when I slid that confidence bar to the left to make it smaller, what happened to the size of those bars? They got smaller. So smaller means a smaller margin of error. So if I make a lower confidence, I actually have a smaller margin of error. So that one is 2. For a fixed margin of error, it doesn't really matter that much. What matters is, do larger samples provide greater confidence? If you flip the fair coin more often, are you more confident that it's fair or not? Yes, that one's good. You can get a smaller margin of error by selecting a bigger sample. So as the sample size goes up, what happens to the standard deviation of your normal curve? It starts to narrow, right? So isn't that a smaller standard deviation? So that's the other one that's true. And then this one, that's wrong for 2 reasons, but the main one is a larger sample size would make a smaller margin of error. Not big. So those are the do X ones. Questions on any of those? So there's actually, I don't know if anyone noticed, but if you turn to the very back page, there's the answers for each one and explanations. So if you're at home and you're like, wait, why did he say this is true? Like, you can look back and see. But then I want you to try this ACT one. So we took a 95% confidence interval, and my confidence interval came out to 15 to 90. So there, I'm not going to tell you that. Try to figure out how many you think are true, and then I'll tell you how many are true, and you can go back and like adjust. Go through. All right, there's four true statements. You got four? Hope it's the right ones. All right, number one. Multiple intervals, long run, capture the true or contain the true mean. What do we think of that one? Solid. That's a good one. Number two, 95% chance that they'll lie within this specific sample interval. What about that one? That's false because they're talking about like this specific interval. This specific interval doesn't really matter. Same with this one. This is talking about this specific interval. Doesn't really matter. 4 is also talking about this specific interval, but we need to talk about like over the long run, all samples. So number 5, when I use statistically correct methods, that's like saying if I behave correctly. That's a weird phrase, but 95% of all samples and then contain the true mean. What do you think of that one? Yeah. That one's good. Keep in mind, we don't normally know the true value. It's in this sentence up here that it's normally distributed with a mean of 20. So this actually didn't capture the true value. So this could, if it just said capture the true mean, it didn't say on 20, it's still fine because we often don't know the true value. Number 6, again, it's referring to my one sample. That is not good. Questions on 1 through 6. Sounds like the confidence interval wording. Alright, larger interval increases my confidence level. So if I give you a bigger window, are you more confident that you're correct? Yep. Some is true. lower confidence level would increase my margin of error. So if I'm going to be less confident that I'm correct, do I get a bigger window? No, less confident I'm correct would be like a smaller window. 8 is backwards. Number 9, if I increase the confidence level, if I have to be more confident that I'm right, don't I need a bigger margin of error? So I want to be more confident that I'm capturing the true value. So number 9 is garbage. Number 10, decreasing the confidence will decrease the margin of error. Let me try to explain this like this way too. So your margin of error is this. Those two things multiplied by each other. So if I decrease the confidence level, that's going to decrease Z star. Well, if I decrease Z star, then the margin of error is multiplying Z star times this other thing. If I decrease Z star, I have to decrease the margin of error too. That's like the mathematical way to look at it. So 10 is correct. And then 11, again, references like our specific samples. So it's questions on anything on there? Everybody have all 4 right? Like you had 4 and the right 4? That's hard. Yeah. Questions I can answer them? Yeah. Good question. Or you just answer them? I thought you were like okay. So I got. We are starting. So there's 2 major topics in this chapter. This is kind of wrapping up the first one. Tomorrow we'll start the second one. So you should have your notes for 6.2 done by tomorrow, and then we'll start doing 6.2 in class tomorrow. You will have a test before spring break.